Today the topic is moment of inertia. In previous lecture we discussed about how to find moment of inertia of circular lamina. Today we discuss about how to find moment of inertia of a triangular section. Okay. To discuss how to find moment of inertia of a triangular section, we must go through the theorem of parallel axis. Okay. The theorem of parallel axis states if the moment of inertia of a plane area about an axis passing through its CG is denoted by IG, then moment of inertia of the plane area about any other axis AB parallel to the first axis and at a distance h from the CG, okay, is given by this equation. Okay, that means IAB is the moment of inertia with respect to this axis. Okay, with respect to this axis, the moment of inertia of this plane area is IAB, and moment of inertia about this axis, that is IG. This axis is an axis which is passing through the CG of the plane area, and this AB axis is parallel to this axis, okay, and at a distance h, okay. Then the moment of inertia with respect to this axis, that is denoted by IAB is equal to IG plus AH square, where small a is the area of the section and h is the distance between this axis to the CG of the plane area. Okay. Now this is the theorem of parallel axis. With this theorem, with the help of this theorem, we find out the moment of inertia of triangular section. Okay. Moment of inertia of a triangular section. Okay. Consider this is a triangular section. That is, nomenclature is A, B, and this is C. Okay. The base is B. The base is B. Okay. And the height of this triangular section is H. Now we have to find out the moment of inertia of this triangular section. Okay. So first consider an elementary small strip, okay, PQ, which is parallel to its base. This is an elementary strip, that is PQ, and parallel to its base. This elementary strip has a thickness dx. This elementary strip has a thickness dx. Okay, the thickness is dx. Okay, and this elementary strip has at a distance from its apex, that is x. Okay, the thickness here, the thickness is dx, and this elementary strip has a distance x from its apex. Okay. Now from the geometry we can write as PQ by BC, that should be equal to x by h. Okay. From the geometry we can write this, that should be equal to PQ should be equal to BC into x by h. Okay. So PQ is equal to, PC is the base of the triangle, that is small b, so it should be written as bx by h. Okay, now the area of the small strip, area of the elementary strip, that should be equal to the thickness multiplied with the distance pq, that is bx by h. So bx by h multiplied with thickness is dx. Okay, so this quantity is the area of the elementary strip. Okay, now the moment of inertia of the elementary strip about the axis passing through BC. Moment of inertia of the elementary strip about an axis passing through its BC. That means an axis pass through this base here. About this axis should be equal to area multiplied with the distance of the strip from this axis. The area is bx by h into dx, and the distance of this strip from this axis, that should be equal to h minus x, because height, this is the h and this distance is x, so the distance between this strip and this axis should be h minus x and distance square. Okay, area multiplied with distance square. Okay, so this quantity indicating the moment of inertia of the strip only. Okay, now we have to find out the moment of inertia of the whole section. So we have to integrate this quantity. So moment of inertia of the whole triangular section, that should be equal to with respect to axis AB. We find out the moment of inertia of this axis, so it is mentioned here. Okay, which is denoted by I suffix, sorry, AB, no, it is not AB, that is the axis BC. So I suffix BC. Okay, that should be equal to integration of this whole quantity bx by h minus x square into dx, this, and the limit should be 0 to h, because when the strip is at here, the distance should be 0 from this axis, and when the strip should be at its apex, the distance should be the height of the triangle. So the limit should be 0 to h. Okay, so it should be equal to b by h is the constant, and integration 0, limit is 0 to h, x into h minus x square, it should be h square plus x square minus 2hx dx. Okay, that should be equal to b by h, that is constant, and 0 to h, that is the limit, x multiplied with this quantity, that should be x h square plus x cube minus 2h x square dx. Okay, now that should be equal to b by h. Okay, b by h, integration of this quantity should be h square, x, integration of x should be x square by 2, plus integration of this quantity should be x to the power 4 by 4, that is integration of this quantity should be minus 2h, that is constant, into x square, that should be equal to x cube by 3. Okay, and the limit is equal to 0 to h. Okay, 0 to h. Okay, if you simplify this quantity, that should be equal to IBC is equal to BH cube by 12. So this is the moment of inertia of the triangular section with respect to axis BC, with respect to an axis passing through its base. Now we have to find out the moment of inertia of the triangular section about an axis passing through its CG and parallel to its base. Okay, suppose the CG is here. The CG should be at a distance from its base, that should be equal to h by 3. Okay, now from the equation, that is the equation of theorem of parallel axis, that is equal to, you can write as this: IBC is equal to IG plus A into h square, or IBC is equal to BH cube by 12. Okay, and IG is the moment of inertia of the triangular section about an axis passing through its CG and parallel to its base, and the area of the triangular section should be half into BH, that is BH by 2. Okay, and this h means here equation, this h and this h is not same. You can change this quantity as a into L square, where L is the distance between the CG and the axis BC. Okay, that is equal to h by 3. Okay, so in place of AL you may write as h by 3 whole square. Okay, now if you simplify this equation, the IG should be equal to BH cube by 36. Okay, so the moment of inertia of a triangular section about an axis passing through its CG, and parallel to its base should be equal to BH cube by 36, and the moment of inertia of the triangular section with respect to an axis passing through its base should be equal to BH cube by 12. Okay, this is the moment of inertia of the triangular section with respect to two different axes. Okay, so if in any numerical the value is given, the height and width, you find out the moment of inertia with respect to an axis passing through its CG or an axis passing through its base. Okay, in next video we go through the numerical. Okay, simply numerical regular section. Okay, thank you.